On June 19th, 1944, at 1300 hours, Vice Admiral Jisaburo Ozawa stood in the flag plot aboard the carrier Taiho, watching radar plots track incoming American aircraft. The symbols on the plotting board told a story that shouldn't have been possible. 15 American carriers were operating as a single task force less than 200 miles from his position. 15 carriers. When Ozawa had entered the Imperial Japanese Navy in 1909, the entire world possessed exactly 0 aircraft carriers. When Japan launched its first carrier, Hosho, in 1922, the concept was still experimental. By 1941, Japan had built the finest carrier force ever assembled. 6 fleet carriers, all modern, all battle-tested. The Americans had 4. Now, in mid-1944, Ozawa commanded 9 Japanese carriers facing an American task force with 15 carriers. But the numbers on that plotting board weren't what kept Ozawa awake. He had received intelligence reports 3 weeks earlier that changed everything. The Americans weren't just operating 15 carriers today. They had 24 Essex-class fleet carriers either in service or under construction. 24 identical ships, all built to the same design, all carrying 90 aircraft, all capable of 33 knots. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. 24 carriers of a single class. Japan had built 6 fleet carriers total in 20 years of carrier development. The Americans had built 24 fleet carriers of one class in less than 3 years. The mathematics made no sense unless you understood one terrible truth. Japan had already lost the war. The outcome wasn't determined by this battle or any battle to come. It was determined by welding torches in American shipyards, by assembly, lines producing aircraft at impossible rates, by an industrial capacity so vast that Japanese planners had failed to comprehend it, even when the evidence sat in front of them. Ozawa knew the numbers because intelligence staff had compiled them into a report that circulated among senior flag officers in May of 1944. The report was classified at the highest level. Distribution was limited to fewer than 30 officers. Reading it felt like watching your own death sentence being written in careful, bureaucratic language. The report detailed American carrier construction with brutal precision. Essex-class carriers, 24 ships authorized, 17 already commissioned, 7 more under construction. Independence-class light carriers, 9 ships converted from cruiser hulls, all commissioned between January and December of 1943. Casablanca-class escort carriers, 50 ships authorized, construction proceeding at rate of 1 carrier every 8 days. The numbers continued for pages. Every category showed American production at levels that seemed physically impossible. But reconnaissance photographs confirmed it. Radio intercepts confirmed it. Combat encounters confirmed it. The Americans were building carriers faster than Japan could train pilots to oppose them. The question that haunted Ozawa and every other Japanese flag officer who had read that report was simple and terrible. How did we miss this? Japan entered the war with overwhelming confidence in its carrier force. That confidence was justified by decades of experience and careful development. The Imperial Japanese Navy had operated carriers longer than any navy in the world. Their doctrine was refined through years of combat in China. Their pilots were superbly trained. Their aircraft were proven in battle. On December 7, 1941, 6 Japanese carriers launched a strike against Pearl Harbor that crippled the American Pacific Fleet. The attack was flawless. American battleships burned. American aircraft were destroyed on the ground. American naval power in the Pacific was broken. For 6 months, Japanese carriers dominated the Pacific. They supported the invasion of the Philippines, the conquest of the Dutch East Indies, the drive into the Indian Ocean. Every operation succeeded. Every battle was won. American carriers appeared occasionally, fought defensive actions, and withdrew. The war was proceeding exactly as Japanese planners had predicted. Then came Midway. On June 4, 1942, American dive bombers attacked 4 Japanese carriers in 6 minutes of combat that changed the war. Akagi, Kaga, Soryu, Hiryu, gone. 4 fleet carriers sunk. Japan lost 2/3 of its Pearl Harbor strike force in a single morning. The loss was catastrophic, but not necessarily fatal. Japan still had 2 fleet carriers operational, Shokaku and Zuikaku, plus several light carriers. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. More critically, Japan had the shipyards and the expertise to replace losses. At least, that's what planners in Tokyo believed. The Naval General Staff immediately began calculating replacement timelines. Building a fleet carrier required approximately 3 to 4 years from keel laying to commissioning. Japan had 3 major naval shipyards capable of building fleet carriers: Yokosuka Naval Arsenal near Tokyo, Kure Naval Arsenal near Hiroshima, and Kawasaki Shipyard in Kobe. If all 3 yards focused on carrier construction, Japan could theoretically replace the 4 lost carriers in 4 to 5 years. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. That timeline was unacceptable. The war couldn't wait 5 years, so planners developed an alternative approach. They would build 1 new fleet carrier, Taiho, which had already been laid down before Pearl Harbor. They would convert merchant ships and seaplane tenders into light carriers for interim capability. They would design a new class of simpler, smaller fleet carriers that could be built faster. The Unryu class would be Japan's answer to rapid carrier construction. The plan looked reasonable on paper. Taiho would provide heavy fleet carrier capability. The conversions would fill gaps in carrier strength. The Unryu-class ships would eventually restore Japanese numerical superiority. It was logical, carefully calculated, properly resourced. It failed completely. Not because Japanese shipyards couldn't build carriers, they could and did, but because while Japan was building 1 new fleet carrier, the Americans were building 24. The Essex-class program began in July of 1940. The United States Navy had watched Japanese and British carrier development throughout the 1930s with growing concern. America's existing carriers, the Lexington and Saratoga-class ships, were conversions from battle cruiser hulls. They were large and capable, but their designs reflected compromise between their original battle cruiser specifications and their carrier modifications. The Yorktown-class carriers that followed were purpose-built designs incorporating lessons from earlier carriers. They were effective ships. 3 Yorktown-class carriers fought at Midway. 2 were sunk. The surviving ship, Enterprise, became the most decorated carrier in American naval history. But the Yorktown class had limitations. They displaced 20,000 tons, carried approximately 80 aircraft, and required 3 to 4 years to build. The Navy wanted something better. The Essex-class design emerged from years of careful analysis of carrier operations and combat requirements. The new carriers would displace 27,000 tons standard, making them significantly larger than previous American carriers. They would carry 90 aircraft, providing greater strike capability. They would incorporate armor protection over magazines and machinery spaces, improving survivability. They would mount extensive anti-aircraft armament for self-defense. They would have better damage control systems with improved compartmentalization and redundant systems. Most critically, they would be designed for rapid construction using techniques that would allow multiple ships to be built simultaneously at different shipyards. The Navy authorized the first 4 Essex-class carriers in July 1940. Authorization meant Congress approved funding, and the Navy could order construction to begin. The first ship, USS Essex, had its keel laid at Newport News Shipbuilding in Virginia on April 28, 1941. That was more than 7 months before Pearl Harbor. The United States was still officially at peace. But American naval planners understood war was coming, and they were preparing industrial mobilization before the first shot was fired. Essex was launched on July 31, 1942, 15 months after her keel was laid. She was commissioned on December 31, 1942, 20 months after construction began, 20 months from keel laying to operational carrier. That was fast by any standard. Japanese carriers typically required 30 to 40 months from keel to commissioning, but Essex was just the beginning. While Essex was under construction, the Navy authorized more carriers. 4 in 1940, 11 more in 1941, another 9 in 1942, 24 Essex-class carriers authorized in 3 years. This wasn't expansion. This was industrial mobilization on a scale that had never been attempted for warship construction. Japanese naval intelligence monitored American carrier construction through multiple sources. Reconnaissance aircraft photographed American shipyards when possible. Neutral merchant sailors reported what they saw in American ports. Technical publications occasionally mentioned construction programs. Radio intercepts sometimes revealed unit designations or ship movements. The intelligence was fragmentary but consistent. The Americans were building carriers. The question was, how many and how fast? Early Japanese estimates assumed American carrier construction would follow patterns similar to Japanese experience. Building a fleet carrier required specialized shipyards, highly skilled workers, years of expertise. The Americans had fewer carrier-capable shipyards than Japan. Their workforce was less experienced in naval construction. Their steel allocation had to be divided between Navy ships, merchant construction, and Army requirements. Intelligence officers in Tokyo calculated that America might complete 6 to 8 fleet carriers by 1944. That would give the Americans numerical parity with Japan's pre-war carrier force. Concerning, but manageable, Japan would still have the advantage of superior pilot training, better aircraft, and more refined carrier doctrine. The estimates were wrong by a factor of 3 to 1. By December 1943, the Americans had commissioned 11 Essex-class carriers, 11 ships in 1 year. Japan commissioned 1 carrier that year, Taiho. The ratio was 11 to 1 in America's favor, and the gap was widening. What Japanese intelligence failed to understand was that American shipbuilding had undergone a revolution. The revolution wasn't technological. American shipyards didn't have better tools or more advanced equipment than Japanese yards. The revolution was organizational. American industry approached carrier construction the way it approached building automobiles or refrigerators or any other manufactured product. Break the design into components. Build components in separate facilities using specialized workers. Assemble components using standardized methods. Test and verify at every stage. Deliver the finished product as quickly as possible. This was mass production applied to warship construction. It was a fundamentally different approach than traditional shipbuilding, which relied on skilled craftsmen custom-fitting each piece in careful sequence. Mass production was faster, required less skilled labor, and could be scaled up dramatically by building more factories to produce more components. Newport News Shipbuilding in Virginia led the Essex-class construction program. Newport News was the largest private shipyard in America and had been building warships since the 1890s. They understood traditional naval construction thoroughly, but they also understood that traditional methods were too slow for wartime requirements. Newport News reorganized their entire construction process around prefabrication and modular assembly. Instead of building a carrier from the bottom up, one piece at a time in the shipway, they built major sections in separate facilities, then assembled those sections into a complete ship. The flight deck was constructed as sections in a dedicated building 500 feet long. Steel plates were cut to precise specifications using templates that ensured every piece was identical. The cut plates were moved to assembly jigs, where they were aligned and welded together into deck sections 120 feet long by 90 feet wide. Each completed deck section weighed hundreds of tons and required massive cranes to move it to the shipway. But building the deck in sections outside the ship allowed the work to proceed in parallel with hull construction, cutting months off the construction schedule. The hangar deck received similar treatment. Sections were built on their sides in a separate facility, complete with roller tracks for moving aircraft, lighting systems, ventilation ducts, and fire suppression equipment. When the sections were complete, they were lifted into the hull as finished assemblies rather than being constructed piece by piece inside the cramped confines of the ship. Elevator assemblies. the massive hydraulic platforms that lifted aircraft from the hangar deck to the flight deck, were built and tested in a dedicated shop. The entire elevator mechanism was assembled, connected to temporary hydraulic power, and operated dozens of times to verify performance. Only after testing confirmed the elevator worked properly was it installed in the carrier. This approach meant that when the elevator went into the ship, it worked. There was no extended troubleshooting period inside the vessel where access was difficult and repairs were time-consuming. Propulsion systems required the most complex machinery aboard any carrier. Each Essex-class ship needed 4 turbines, 8 boilers, reduction gears, propeller shafts, condensers, and thousands of feet of steam piping to move 150,000 shaft horsepower from the engine rooms to the propellers. Traditional shipbuilding installed this machinery piece by piece. Boilers were lowered into place, turbines were positioned, piping was custom-fitted to connect everything. The work took months and required highly skilled pipe fitters who could measure, cut, bend, and weld pipes in the confined spaces of the machinery compartments. Newport News created propulsion modules. Each module contained 1 complete turbine set, 2 boilers, and all associated piping pre-assembled in a separate facility. The modules were built in a shop with easy access from all sides, allowing workers to install piping without crawling through narrow passages. The complete module was test-fired using temporary steam connections. Engineers verified that pressures, temperatures, and power output met specifications before the module ever reached the ship. When the carrier hull was ready, cranes lifted entire propulsion modules, weighing hundreds of tons into the machinery spaces. Workers connected steam lines to adjacent modules, connected electrical cables for control systems, and the propulsion system was operational. Installation time dropped from 3 months to 3 weeks. This modular approach extended throughout the ship. Radar systems were pre-assembled and tested. Complete radar masts with antennas, transmitters, receivers, and power supplies were built in electronics shops, then installed as units. Gun mounts arrived from manufacturers as complete assemblies with all mechanical, hydraulic, and electrical systems already installed and tested. Workers bolted or welded the gun mounts to their foundations, connected ammunition hoists and power supplies, and the weapons were ready. Even crew accommodations were prefabricated. Berthing compartments with bunks, lockers, lighting, and ventilation were assembled in specialized shops, then lifted into position in the hull. The result was carriers built in sections by workers who specialized in building those specific sections, then assembled in the shipway in a fraction of the time traditional methods required. USS Essex took 20 months from keel to commissioning. That became the baseline. Every Essex-class carrier that followed was built faster as workers became more experienced and prefabrication techniques were refined. USS Lexington, the second Essex-class carrier, was commissioned after 17 months of construction. USS Bunker Hill took 18 months. USS Intrepid took 16 months. By mid-1943, Newport News and other yards building Essex-class carriers had reduced construction time to 14 to 16 months consistently. Some ships were completed in less than 13 months from keel laying to commissioning. The Americans were building fleet carriers twice as fast as Japan could build comparable ships, and they were building 3 times as many. But speed was only part of the story. The other part was scale. The United States didn't just build carriers at one shipyard. They built carriers at multiple yards simultaneously using the same designs and the same methods. Newport News Shipbuilding in Virginia built 9 Essex-class carriers. Bethlehem Steel's Quincy Yard in Massachusetts built 4. Philadelphia Naval Shipyard built 5. Norfolk Naval Shipyard built 3. New York Naval Shipyard built 3. 5 shipyards, all building identical carriers, all using the same prefabricated components, all following the same assembly sequence. This was genuine mass production. When Newport News solved a construction problem, all 5 yards benefited. When Bethlehem Steel developed a better method for installing some system, all 5 yards adopted it. The shared design and shared methods meant improvements propagated across the entire program instantly. Japanese carrier construction never achieved this level of coordination. Each Japanese carrier was essentially a unique design even when ships were supposedly built to the same class. Taiho incorporated improvements over earlier carriers. The Unryu class incorporated different improvements. Every ship required custom engineering work, custom tooling, custom training for workers. Nothing was truly standardized. That meant every ship took the same amount of time to build, because every ship was essentially a one-off project. The scale of American production became undeniable in early 1944 when Japanese reconnaissance aircraft photographed Pearl Harbor and counted carrier silhouettes at anchor. The photographs were analyzed by intelligence officers in Tokyo, who cross-referenced ship profiles with known American carrier types. The analysis identified 12 Essex-class carriers in various states of readiness. 12 identical ships, all at one base, all preparing for operations. That single photograph told Japanese naval leadership everything they needed to know about the industrial gap they faced. 12 carriers of one class at one location meant dozens more were operating elsewhere or under construction. The Americans weren't just building replacement carriers, they were building an entirely new fleet from nothing in less than 3 years. Vice Admiral Ozawa received briefings on American carrier strength throughout early 1944 as he prepared for what everyone knew would be a decisive battle. The briefings included detailed intelligence estimates of American force composition. By May 1944, intelligence staff estimated the Americans had operational 17 Essex-class carriers, 9 Independence-class light carriers converted from cruiser hulls, and over 40 escort carriers of various types supporting amphibious operations and convoy protection. Total American carrier strength exceeded 70 ships. Japan had 9 operational carriers. The ratio was roughly 8-1 in America's favor, but raw numbers understated the actual disparity. American carriers were larger, carried more aircraft, had better radar, better damage control, better anti-aircraft defenses. An Essex-class carrier embarked 90 aircraft. A Japanese fleet carrier embarked 65 to 75 aircraft, depending on type. An Essex-class carrier had comprehensive radar coverage that could detect incoming aircraft at 150 miles. Japanese carriers had limited radar that often detected aircraft only at 30 to 50 miles under ideal conditions. An Essex-class carrier had proximity-fused anti-aircraft shells that detonated automatically near aircraft without requiring direct hits. Japanese carriers used contact and time-fused ammunition that was far less effective. An Essex-class carrier had extensive armor protection over magazines, machinery spaces, and aviation fuel storage. Damage control parties numbered in the hundreds with redundant equipment and supplies throughout the ship. Japanese carriers had minimal armor except on Taiho, which was specifically designed with improved protection. Damage control parties were smaller with less equipment and less training. Every technical comparison favored American carriers. Combined with numerical superiority of 8-1, the actual combat power ratio was closer to 12 or 15-1. Japan was not facing a numerically superior enemy. Japan was facing an enemy with overwhelming material superiority at every level. The Battle of the Philippine Sea in June 1944 demonstrated what those numbers meant in combat. American Task Force 58, under Admiral Mark Mitchell, deployed 15 carriers, 7 Essex-class fleet carriers, 8 Independence-class light carriers. Those 15 carriers embarked 956 aircraft. Supporting the carriers were 7 battleships, 8 heavy cruisers, 13 light cruisers, and 69 destroyers. The entire task force comprised over 100 ships manned by approximately 70,000 sailors. Vice Admiral Ozawa's mobile fleet comprised 9 carriers, 3 fleet carriers including Taiho, Shokaku, and Zuikaku, 6 light carriers. Those 9 carriers embarked 450 aircraft, less than half the American total, and those aircraft were flown by pilots with far less training than their American counterparts. Before the war, Japanese naval aviators trained for 2 years before their first carrier landing. They accumulated hundreds of flight hours. They practiced navigation, gunnery, formation, flying, night operations, carrier approaches, until every maneuver became instinctive. By June 1944, Japan no longer had 2 years to train pilots. Fuel shortages limited training flights. Experienced instructors were dead, killed in earlier battles. Training programs were compressed from 24 months to 12 months, then to 6 months. Pilots graduated to fleet squadrons with 100 flight hours instead of 500. They could fly their aircraft and operate their weapons, but they lacked the experience to survive combat against veteran American pilots who had been fighting since 1942. The battle began on June 19th when Ozawa launched his first strike wave at 7:30 in the morning. 69 aircraft, a mixed formation of Zero fighters, Val dive bombers, and Jill torpedo bombers headed toward the American task force 200 miles away. American radar detected the incoming strike at 150 miles. Fighter directors aboard the carriers vectored 40 Hellcat fighters to intercept. The Hellcats hit the Japanese formation 60 miles from the carriers, far beyond visual range of the American ships. In the first 10 minutes of combat, American fighters shot down 42 Japanese aircraft. The formation disintegrated. Some aircraft turned back, others scattered trying to evade the Hellcats. A few continued toward the carriers. Those that continued encountered a second wave of American fighters, then a third wave, then massed anti-aircraft fire from the screening destroyers and cruisers. 8 aircraft broke through to the carriers. They scored no hits. 4 aircraft returned to their carriers. 65 Japanese aircraft lost. 0 American carriers damaged. The exchange ratio was catastrophic, but it got worse. Japan's second strike launched at 8:56 in the morning, 109 aircraft. The strike met the same layered defense. American radar detected them. American fighters intercepted them far from the task force. American pilots destroyed 97 aircraft before they reached attack range. The third strike, 107 aircraft, achieved a single bomb hit on the battleship South Dakota, causing minor damage. The Americans lost 29 aircraft in the day's fighting. Japan lost 300. The Americans called it the Great Marianas Turkey Shoot. The name was cruel but accurate. American fighters slaughtered Japanese strike aircraft the way hunters shoot turkeys. The battle demonstrated the cumulative advantages of superior aircraft, superior pilots, superior radar direction, and superior numbers. Japanese pilots fought bravely. They pressed attacks despite losses. They flew their aircraft to the limit of their capabilities. It didn't matter. Courage couldn't overcome technical inferiority, numerical disadvantage, and inadequate training. But the air battle was only half of what happened on June 19th. While Japanese aircraft were being destroyed by American fighters, American submarines were hunting Japanese carriers. USS Albacore detected Taiho's task group and maneuvered into attack position. At 0920, Albacore fired 6 torpedoes at Taiho from a range of 3,200 yards. 5 torpedoes missed. 1 struck Taiho on the starboard side forward near the aviation fuel tanks. The damage should have been manageable. Taiho was designed to survive torpedo hits. She had extensive compartmentalization, reinforced bulkheads, and modern damage control equipment. The single torpedo flooded one compartment and ruptured some fuel lines, but didn't threaten the ship immediately. A young damage control officer made a decision that killed Taiho. He ordered the ship's ventilation system turned on to clear gasoline fumes from the hangar deck. The ventilation system was designed to move air through the ship for crew comfort. It was not designed for damage control. Instead of venting gasoline fumes overboard, the ventilation system spread fumes throughout the ship. For 6 hours, gasoline vapor accumulated in compartments, passageways, and machinery spaces. At 15:32, a spark ignited the vapor. The explosion was catastrophic. It tore through the ship from bow to stern. Elevator platforms were blown upward. The flight deck buckled. Internal bulkheads collapsed. Fires erupted throughout the vessel. Taiho lost power, lost steering, began listing. At 16:28, less than 1 hour after the explosion, Admiral Ozawa transferred his flag to the cruiser Haguro. At 19:28, Taiho sank stern, first taking 1,272 men with her. 32 months to build. 3 months in operational service. Gone. While Taiho was dying, USS Kavala attacked another Japanese carrier group. At 12:20, Kavala fired 6 torpedoes at the carrier Shokaku. 3 torpedoes struck the carrier on the starboard side. Massive explosions ripped through the hangar deck where fueled and armed aircraft were being prepared for strikes. Secondary explosions from aviation fuel and ordnance followed. Fires spread rapidly. Shokaku had survived 3 years of combat. She had fought at Pearl Harbor, Coral Sea, and Santa Cruz. She was one of the most successful carriers in the Imperial Japanese Navy. 4 American torpedoes killed her in minutes. She sank at 15:01, taking 1,263 men to the bottom. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. 3 Japanese carriers lost in one day. Taiho, Shokaku, and the light carrier Hio, which was sunk by aerial torpedoes later that evening. The Americans lost 0 carriers. They lost 29 aircraft. Most of the pilots were recovered. Japan's losses were absolute and permanent. 3 carriers that could never be replaced. 300 aircraft gone. Hundreds of pilots killed, including many of the remaining experienced aviators who represented years of training Japan could no longer provide. The Battle of the Philippine Sea destroyed Japan's carrier aviation capability permanently. The mobile fleet retreated to Okinawa with 6 carriers and fewer than 100 operational aircraft. Those carriers would never again conduct major offensive operations because Japan lacked the pilots and aircraft to operate them effectively. But what broke Japanese morale more than the tactical defeat was the strategic understanding that followed. Officers who survived the battle and returned to base filed detailed reports describing American carrier operations. The reports mentioned ship names: USS Essex, USS Lexington, USS Yorktown, USS Bunker Hill, USS Wasp, USS Hornet, USS Enterprise. Some of those names were familiar. Yorktown and Hornet had been sunk earlier in the war. Except these weren't the same ships. These were new carriers bearing the names of vessels lost in combat. The Americans had built so many carriers they were naming new ships after carriers sunk just 2 years earlier. That told Japanese naval officers everything. When Japan lost a carrier, it was a national tragedy. Prayers were offered. Memorial services were held. The loss represented years of construction time and irreplaceable capability. When America lost a carrier, they commissioned a new one and gave it the same name. The replacement ship was often superior to the original. Losses were tactically unfortunate, but strategically irrelevant. Intelligence staff in Tokyo compiled after-action reports from Philippine Sea and cross-referenced American carrier sightings with known ship identities. The analysis identified 17 Essex-class carriers that had participated in combat operations or been photographed at American bases since January 1944. 17 ships of one class, all commissioned within 18 months. The analysis continued. Based on observed American construction rates and the consistent 16 to 18-month building time for Essex-class carriers, intelligence officers projected that American yards would complete at least 20 to 22 Essex-class carriers by the end of 1944. That estimate was conservative. The actual number would be 24 Essex-class carriers commissioned by the time Japan surrendered, with 8 more under construction when the war ended. But even the conservative estimate of 22 carriers told Japanese planners they had no path to victory. 22 Essex-class carriers represented nearly 2,000 embarked aircraft. Japan's entire remaining carrier force could embark perhaps 400 aircraft if fully equipped, which it wasn't because aircraft production couldn't keep pace with losses. The Americans could lose half their Essex-class carriers, 11 ships sunk, and still have numerical superiority over Japan's entire carrier force. And the Americans weren't going to lose 11 carriers because Japan no longer had the aircraft or pilots to inflict such losses. The mathematics of the situation were absolute. Japan could not win a carrier war against an enemy that built carriers at 10 times Japan's production rate. Every tactical victory would be meaningless. Every Japanese carrier lost was irreplaceable. Every American carrier lost would be replaced within months by 2 new ones. Some Japanese naval officers argued that superior tactics and fighting spirit could overcome numerical disadvantage. They pointed to historical examples where smaller forces defeated larger ones through superior strategy. Those arguments collapsed when confronted with the actual numbers. Superior tactics require approximate parity in capability. A force outnumbered 2-1 or 3-1 might overcome the disadvantage through brilliant maneuvering or unexpected approaches. A force outnumbered 10-1 cannot win regardless of tactical skill. There is no tactical solution to overwhelming material superiority. The Americans didn't need brilliant tactics. They could afford to make mistakes, suffer losses, learn from experience, and come back stronger because their industrial base produced replacements faster than combat consumed them. Captain Toshikazu Ome served in the Naval General Staff Operations Section and was responsible for analyzing the Philippine Sea battle results. Ome had studied American naval capabilities for years. He understood American industrial capacity better than most Japanese officers. After Philippine Sea, Ome wrote a classified assessment for senior naval leadership, examining Japan's strategic position. The assessment was brutally honest. It stated that Japan had entered the war with fundamental miscalculations about American mobilization capacity. Specifically, Japanese planners had failed to understand that American industry operated on principles completely different from Japanese industry. Japan built weapons the way artisans create custom products, carefully, slowly, emphasizing quality and craftsmanship. America built weapons the way factories produce automobiles, quickly, in volume, emphasizing standardization and interchangeable parts. The Essex-class carrier program demonstrated this difference perfectly. 24 identical ships built simultaneously at 5 different shipyards, using prefabricated components and standardized assembly methods. This was industrial mass production applied to warship construction. Japan had no equivalent capability and could not develop such capability during wartime because it required infrastructure, workforce training, and supply chain organization that took years to establish. Ome's assessment concluded that Japan's only rational strategic option was to seek negotiated settlement immediately before American material superiority, made Japan's bargaining position completely hopeless. Every month, the war continued weakened Japan's position as American production added more carriers, more aircraft, more trained pilots. The assessment was read by senior officers. It was discussed quietly. It was then classified at the highest level and suppressed. The political implications of admitting Japan had lost the war were unacceptable. If the military acknowledged the war was unwinnable, civilian government might demand surrender. If the emperor understood the military had led Japan into an unwinnable war, there would be demands for accountability. If the Japanese people learned their sons were dying in battles that could not change the war's outcome, morale would collapse. The institutional incentive was to continue fighting regardless of strategic reality. By October 1944, Japan's remaining carriers were used as decoy forces. At the Battle of Leyte Gulf, 4 Japanese carriers with almost no aircraft aboard sailed north to draw American carriers away from the main battle area. The plan worked. American carrier aircraft attacked the decoy force and sank all 4 carriers. Zuikaku, the last survivor of the Pearl Harbor attack force, went down on October 25, taking nearly 900 men with her. The sacrifice achieved nothing. American escort carriers in Leyte Gulf fought off Japanese surface forces anyway. Japan's carrier aviation had become so ineffective that carriers were more valuable as bait than as combat units. By November 1944, Japan had 0 operational fleet carriers. The Americans had 28 Essex and Independence-class carriers in service with more commissioning every month. The strategic implication was final and absolute. Japan could not contest American naval control anywhere American carriers could operate. Japanese surface forces couldn't sortie without air cover. Japanese supply lines couldn't function within carrier strike range. Japanese island garrisons couldn't be reinforced or resupplied. The Americans controlled the Pacific Ocean completely. They could strike anywhere, land forces anywhere, blockade Japan's home islands without meaningful opposition. The war's outcome had been determined by industrial capacity years before the fighting ended, not by battles or tactics or fighting spirit, by assembly lines, welding torches, and shipyard workers in Virginia, Massachusetts, Pennsylvania, and New York, who built carriers faster than Japan could conceive possible. The Essex-class program was just one piece of American industrial mobilization, but it exemplified the fundamental difference between American and Japanese approaches to war production. The United States designed weapons for mass production from the beginning. The Essex-class carriers were intentionally built using methods that could be replicated at multiple shipyards. Components were standardized, so parts built in different factories were interchangeable. Construction was broken into modules that could be assembled by workers with minimal specialized training. Japan designed weapons for performance and quality with less emphasis on production efficiency. Japanese carriers were excellent ships, incorporating the latest technology and careful engineering. But each one required skilled craftsmen, custom fitting, and extended construction time. Quality was high, but quantity was low. In peacetime, the Japanese approach had merit. In wartime, it was fatal. Wars of attrition favor the side that can replace losses faster. America could build 3 Essex-class carriers in the time Japan needed to build 1 Unryu-class carrier. America could lose carriers in combat and have replacements arriving within months. Japan couldn't afford to lose any carriers because replacements took years. This dynamic played out across every category of military production. Aircraft, ships, vehicles, weapons, ammunition. Everything favored the Americans because they had organized their industry for mass production before the war began. Henry Ford's assembly line methods that made automobiles affordable for millions of Americans were applied to building bombers, fighters, tanks, and warships. The same principles worked everywhere. Standardized designs. Break production into simple repetitive tasks. Train workers to do one task well. Assemble components into finished products quickly. The method produced adequate weapons reliably and in tremendous volume. Japanese industry couldn't replicate this approach during wartime. It required factory reorganization, worker retraining, supply chain restructuring, and culture change throughout industry. None of that could happen while fighting a total war that consumed all available resources. So, Japan continued building weapons using traditional methods that produced excellent equipment slowly, while America produced adequate equipment in overwhelming quantities. The Essex-class carriers were excellent ships, superior to Japanese fleet carriers in most categories. But even if they had been merely adequate, 24 adequate carriers would still defeat 6 excellent carriers through sheer numbers. That was the lesson Japanese admirals learned watching American task forces operate with impunity off Japanese coasts in late 1944 and early 1945. American carriers launched 1,000 aircraft strikes against Japanese cities. Japanese air defenses were overwhelmed. Japanese fighters were outnumbered 50-1. Industrial facilities were destroyed. Urban areas were burned. The home islands were blockaded. Starvation loomed. By July 1945, American carrier task forces operated off Japan's coast without opposition. Task Force 38 included 17 fleet carriers and 6 light carriers embarking over 1,500 aircraft. More combat aircraft in one task force than Japan's entire remaining air force. Those carriers launched strikes daily against anything that moved. Japanese aircraft were destroyed on the ground. Japanese ships were sunk in harbor. Japanese trains were strafed on rail lines. The level of American air superiority was absolute. Japanese forces could do nothing but watch and endure. The war ended on August 15, 1945. Japan surrendered not because of the atomic bombs, though those provided convenient political justification. Japan surrendered because continued resistance was physically impossible. The nation had no navy, no air force, minimal ground forces, no food, no fuel, no hope. American industrial power had crushed Japan's ability to resist through sheer material superiority, demonstrated most clearly in carrier production. Japan built 6 fleet carriers during the war. 3 Unryu-class ships plus 3 converted light carriers. The Americans built 24 Essex-class fleet carriers, 9 Independence-class light carriers, and over 100 escort carriers of various classes. The final ratio was roughly 18-1. 18 American carriers for every Japanese carrier built during the war. That ratio determined everything. It determined which navy controlled the Pacific. It determined which nation could project power across ocean distances. It determined who won. The Japanese admirals who counted 24 Essex-class carriers in American service by late 1944 understood instantly they had already lost. The understanding came too late to change anything. The strategic decisions that led to war had been made years earlier based on intelligence estimates that catastrophically underestimated American industrial capacity. Those estimates assumed America would mobilize slowly, using methods similar to Japan's careful measured expansion. The estimates were wrong. America mobilized faster than any nation in history. They converted peacetime industry to war production in months. They trained millions of workers. They built hundreds of factories. They organized supply chains spanning continents. They produced weapons at scales that seemed impossible. The Essex-class program exemplified everything Japan failed to understand about American capabilities. 24 identical fleet carriers built in less than 4 years, using prefabrication, modular assembly, and mass production techniques. Ships launched at multiple yards simultaneously using shared designs and shared methods. Construction times cut in half through organizational innovation rather than technical advancement. This was industrial warfare at its most fundamental level. Not battles, or tactics, or fighting spirit. Steel, welding torches, assembly lines, and workers who turned raw materials into warships faster than the enemy could sink them. Japan entered the war believing tactical superiority and warrior culture could overcome industrial disadvantage. They learned otherwise. Industrial capacity compounds over time. Every ship built makes building the next one easier. Every worker trained makes training the next worker faster. Every process improved makes the entire system more efficient. By mid-1943, American shipyards were completing carriers faster than they could train crews. They had achieved a self-sustaining system where production capacity exceeded immediate requirements. Japan never reached that point. Every carrier they built consumed resources needed for the next one. Every worker trained took time from production. Every process improvement came too late to matter. The gap between American capacity and Japanese capacity wasn't small. It was absolute and unbridgeable. The Pacific War was decided in shipyards, not on battlefields. Battles determined when the war ended. Shipyards determined who would win. The American shipyards, with their prefabrication buildings, their modular assembly methods, their armies of workers who had never built ships before the war, crushed Japan's naval power through industrial output that Japan could neither match nor counter. Vice Admiral Ozawa survived the war. He surrendered Japanese naval forces in September 1945 and testified at war crimes trials. In his testimony, he acknowledged that Japan had fundamentally misunderstood American industrial capacity. Specifically, Japanese naval planning had assumed American carrier construction would be constrained by skilled labor shortages and shipyard capacity limitations. Those assumptions were based on Japanese experience and Japanese industrial practices. They were completely wrong when applied to America. The Americans didn't need decades of shipbuilding tradition. They needed organizational skill and industrial infrastructure. They had both in abundance. The result was 24 Essex-class carriers that represented more combat power than every Japanese carrier built in 30 years of carrier development. That disparity determined the war's outcome with mathematical certainty. Up next, you've got 2 more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.